Hi everybody, in this video I want to explain the idea of reference angles just a little bit more clearly by giving you some more concrete examples. So the whole idea of a reference angle is if I know the sine and cosine of, let's say, pi over 6, then I can use that knowledge to figure out the sine and cosine of other angles. So how do we get the sine and cosine of pi over 6? Well, you might remember from the special triangles video that we have this 30, 60, 90 triangle. So the small angle is pi over 6, the bigger angle is pi over 3. In that 30, 60, 90 triangle, the special relationship that we have among the sides is that the smallest side is half the length of the hypotenuse, which forces this remaining side to be square root of 3 times the length of the smallest side. So we could find that sine of pi over 6 is going to be the opposite, which is x, over the hypotenuse, which is 2x. So we get sine of pi over 6 is a half. And similarly, cosine of pi over 6 is the adjacent, so x root 3 over 2x, which reduces to root 3 over 2. Now, how does this relate to the unit circle picture? Well, the sine tells us the y-coordinate, and the cosine tells us the x. So if I take this information and bring it over to my unit circle, then I can label this point with the x-coordinate being the cosine, so that's square root 3 over 2, and the y-coordinate being the sine, so that's 1/2. Now, this is all stuff that you should understand already, but how would we use this to find, say, sine of, I don't know, 5 pi over 6? So sine of 5 pi over 6 is this angle when we go to here. And the way that we use this information that we've just found is by considering pi over 6 as our reference angle. So the reference angle meaning it is an angle whose cosine and sine we know. And we can use it as a reference for finding the sine and cosine of 5 pi over 6. So notice that the cosine of 5 pi over 6 is going to be the x-coordinate, and the sine of 5 pi over 6 is going to be its y-coordinate, but 5 pi over 6 has the same height as the point that goes with pi over 6. So this y-coordinate is also 1/2, because we know that this is 1/2. And what's the x-coordinate? Well, the x-coordinate is on the negative side of 0, but it's the same distance as the x-coordinate was for pi over 6, so it's just negative square root 3 over 2. We could use this same logic to find the x and y coordinates of 7 pi over 6, which is at this point. In this case, we're in the third quadrant, so both will be negative. But that tells us that the cosine of 7 pi over 6 is negative square root 3 over 2, and the sine is negative 1/2. And finally, I get one more angle's sine and cosine. The cosine of 11 pi over 6 will be square root 3 over 2, because it has the same x-coordinate as this one. And the sine will be negative 1/2, because I've reflected down into this quadrant. Now this doesn't only work with these special angles, although those are the most important because I expect you to memorize the sine and cosine of pi over 6, pi over 4, and pi over 3. But it works for any angle in general. So let's say that we're interested in this small angle, theta. And if I know, let's say that this is 0.9 and this is 0.2. That tells me that cosine of theta equals 0.9 and sine of theta equals 0.2. Now I can get the sine and cosine of a bunch more angles for free just by looking at the reflections. So let's say I want to get the sine and cosine of pi minus theta. Well, that means I should go almost all the way to pi, but I should be short of it by theta. So this green represents pi minus theta. It has the same y coordinate as theta, so this will be 0.2, and it has negative the x coordinate of theta. So this tells me that cosine of pi minus theta equals negative 0.9, and sine of pi minus theta equals 0.2. So that's how we use reference angles. If we know the sine and cosine of one angle, we get the sine and cosine of another angle for free, just by looking at reflections. So I hope that this clarifies the last video a little bit, and we're going to do tons of practice on this in class, and so if you're still feeling uncomfortable, bring your questions to class and we'll work through it together. See you soon.